Welcome back. Today's lesson is on graphing inequalities with two variables. So in class, we've graphed inequalities that looked like this. Let's say x is less than 4. We would look at a number line. Here's our 0, here's our 4. This sign right here in the middle, the less than, would tell us that x cannot be 4, so we would leave it open on 4, and then we would shade in this direction to show that any number that's less than 4 would be a solution to this inequality. But what I've just drawn here only has a single variable. What we're going to learn how to graph today is when an inequality has two variables. We're going to begin by comparing these two graphs. So we have graph A right here in the red, and we have graph B right here in the blue. When we look at graph A, we should notice a couple of things. First, you should notice that it is a solid line. Second, you should notice that it has a y-intercept, which I'm going to represent with B, of 5. And I can tell because if I highlight the y-axis, remember that's this one, my red line crosses right here where y equals 5. You should also be able to figure out the slope of this line. So let's see. If I started at this point right here, my y-intercept of 5, I should notice that I go up 1 and then over 2 to get to my next point. And let's check and see if that's right. Here's another good point. I go up 1 over 2. So that tells me that my slope, which is represented by m, is 1 over 2, because that's my rise. Now let's check out this B graph over here. Looking at it, you should immediately notice that it's not a solid line. It's got all these dashes. So I'm just going to write dashed line. Then let's check out its y-intercept and its slope. So B stands for y-intercept. And when I highlight the y-axis over here, I should see that this blue dashed line is crossing at the same point as the red line was. It's still crossing at 5. So that just means that my y-intercept, B, equals 5. And now let's check out the slope. So I'm going to put a point right at the y-intercept. And then I want to see, and here's another good point, I want to see how many I have to go up, 1, and then how many I have to go over, 1, 2. Okay, let's check another good point. So I go up 1 over 2. All right, that means my slope, m, equals 1 over 2. And then I should notice one other big difference between these two graphs. This graph has all of this part shaded blue, while there's nothing on this graph other than my red line. So down here I'll make a note of shaded. And I can notice that it's shaded beneath the line. So anywhere the line was, I'm going to say shaded below line. Anywhere the line was, beneath it is shaded. So one of these is an equation and one of these is an inequality. We've been studying how to graph and how to write equations of linear functions. So you should recognize that A is actually our equation and B is our inequality. And in fact, here are their written forms. So A is y equals 1/2 x plus plus 5, and B is y is less than 1/2 x plus 5. But you should notice that the slope and the y-intercept were the same. And in fact, when we look at this, the only difference between these two written out is the sign between the y and the rest of the equation. So if it's an equal sign, it becomes an equation. If it's a less than or greater than or less than or equal to sign, it's an inequality. But otherwise, it has the exact same form. So in a direct comparison between a linear equation and a linear inequality, you should notice that the equation has the equal signs. That's what the EQUA part of the word means. And the linear inequality would have one of these four signs: less than, greater than, less than or equal to, greater than or equal to. On the graph, a linear equation will be a solid line, while a linear inequality could be a solid line or a dashed line. There will be nothing else on your graph if it's a linear equation. If it's a linear inequality, there's going to be a shaded solution area. And the reason they have that is because a linear inequality has an infinite number of solutions for each x value, while a linear equation has only one solution for each x value. So let's look at what that means before we practice graphing it a couple of times. So I'm going to take this information, a slope of 1/2 and a y-intercept of 1, and I'm going to look at how it differs from the equation to the inequality. And for the sake of ease, let's evaluate at the point where x equals 2. So for a linear equation, I would write this as y equals 1/2 x plus 1. And as a linear inequality, I would write it as y is less than 1/2 x plus 1. So they have the same slope and the same y-intercept, and we're going to evaluate at this point. So over here, y equals 1/2, and instead of x, I'm going to put 2 plus 1. And over here, y is less than 1/2. Again, I put the 2 plus 1. So y equals 1/2 times 2, well, 1/2 of 2 is just 1, plus 1, y equals 2. Over here, I have y is less than 1/2 of 2 is still 1, 1 plus 1, still 2. So I have two different solutions here. I have y equals 2 where x equals 2. That means in the graph of this equation, on this line, there is the exact point 2, 2. That's where x equals 2, y equals 2. That's what makes it a function. If I input x of 2, I'll get an output of y of 2. Now, in the inequality, I don't have this point. The point of 2, 2 is not on my line. In fact, it's just part of the dashes. This solution means that anytime I put 2 in as my input, every number that is less than 2 is a solution. So anytime x equals 2, y has to be anything less than 2. It could be 1, it could be 1.5, it could be 1.9, it could be -4, -1,000, etc. Any y that's less than 2. And since I can't represent that with a single dot and there's an infinite number of them, it starts to look like I just shaded every number less than 2. That's why we have a shaded solution area on an inequality versus nothing like that on a line. But here's the good news, guys. The good graphing news is that for equations and inequalities, the slope-intercept form is still graphed the same way. You still start at your y-intercept and move using your slope. Once you've plotted out those points, you move on to number 2, where you look at the inequality sign to determine if it's a solid line or a dashed line. If it's a solid line, it just means that at those points, like what we were just looking at those points, so at a point like this, 2 and 2, that could be part of the solution. So instead of a dash, it's a solid line because it means that that is one of the many, many solutions. There's still an infinite number of solutions. It just so means that 2 is one of those. And then your last step will be to look at the inequality sign to determine if you're shading above or below the line. So I created this handy little drawing to help you determine things. So if you have a less than or greater than sign, that means you're going to be using dashes because whatever number y is less than or greater than, it is not part of our solution. So just like when we would do an open dot for any time we saw something like y is less than 4 or y is greater than 4. So if we graphed that, we would have gone to 4 and put an open dot. That's the same idea as the dashes. It means it's not part of the solution. And anytime you have y is less than or equal to or greater than or equal to, you're going to have a solid line, because that or equal to is like when we had this form and we colored in the dot to suggest or to show that 4 is one of the solutions. And then finally, if your sign has the word less in it, like these two, you will shade below. And if it has greater than, like these two, you would shade above. So let's try 2 examples. All right, my first example is right here. Y is less than -3 over 2x plus 2. So I'm going to start by identifying my slope and my y-intercept. My slope is m, and that's the number that is connected to the x, so that's -3 over 2. And my y-intercept is 2. So to start graphing, I go to my y-axis and put a point on 2. And then I use my slope to determine my next point. My slope is -3 over 2. So starting at my y-intercept, I'm going to count down 3 boxes. 1, 2, 3. And to the right 2. 1, 2. That's my next point. Then I'm going to do it again. Down 3 over 2. I've run out of room this way, so I go back to my y-intercept and reverse the pattern. Go up 3 and to the left 2. I've now got all the points that I can fit on my graph. Before I go to draw my line, I need to look at my sign. It says less than. Less than is this sign, which means I'm using dashes. So instead of drawing a solid line, I'm just going to draw a dashed line. I still put arrows on the end because it still continues in both directions. I have one more step. I have to determine, am I shading above or below the line I just drew? This says y is less than. Less than means I'm going to be shading below, because I want all the y values that are less than this. So I look at 2. I want all the numbers less than y equals 2. So that is all of these. And I shade the whole thing in to indicate that it could go on forever. That's it. So let's try one more before you get to work on your practice. My next example is y is greater than or equal to 2x minus 4. So again, I'm going to identify my slope and my y-intercept. So my slope is 2, and I remember that whenever I do slope, I usually want a fraction. So 2 is the same thing as 2 over 1. My y-intercept, I notice it says minus 4, so that means my y-intercept is actually -4. Okay. I'm going to put a point at -4 on the y-axis, because that's my y-intercept, and my slope tells me to go up 2 over 1, up 2 over 1. And I continue that pattern until I run out of room. Go back to my y-intercept, place the last point by reversing the pattern. I went down 2 and to the left 1. And now I look at my sign to tell me if I am doing a solid line or a dotted line. It says greater than or equal to. That's here. Greater than or equal to means a solid line. So I go back to my line, draw it just the way I would if it were an equation, including putting my end arrows. It says greater than or equal to. So greater than, I can go back up here. That's this one, means shade above. So I'm looking for all the numbers that are greater than these values together. So here's my -4. I want numbers greater than my -4. So I shade all of these. Now notice I shaded all the parts that were above the line. So it's not like you only shade one quadrant, meaning I wouldn't only shade in this little square everything that's above the line. And over here I shaded everything that was below the line. So you should see a lot of shading in general. All right, guys, go practice, see what you can make of this.